Stephen, the Teen Services Coordinator with the Denham Springs Walker Branch Library, and welcome back to another STEAM Saturday with Stephen. Today, we are in a new location, if you cannot tell, but first, let's go over our rules. Rule number 1, always have an adult. Rule number 2, make sure you are wearing your safety equipment. I have on my safety glasses and gloves today. Rule number 3, make sure you never put anything in your mouth or eat anything unless instructed to do so. And rule number 4 is follow our instructions as we presented exactly today. Today we are going to learn about and play around with some chemical properties, specifically chemical indicators. Is that right, Dr. Little?
That's correct.
All right, and I have some guests with me today. I have Dr. Gina Little and Mr. Jerry Cottrell from Southeastern Louisiana University. And what are we going to do today, Dr. Little?
We're going to play with some chemical indicators. And chemical indicators are fun because normally what they indicate is that they change colors to indicate something has changed. And so we're going to make things change colors.
That sounds awesome.
So the first one we're going to do is an experiment that you probably don't have access to at home, but it's really fun. So we're going to do some stuff with Indigo Carmine. Mr. Jerry, our lab coordinator, is going to help me. We have some Indigo Carmine. It's a powdered dye, but it's dissolved in a little bit of water. And these are solutions that have glucose, that's a sugar, that's dissolved in water with some sodium hydroxide. So why don't we go ahead and we're going to mix it and see what happens, and then I'll tell you about it.
We're going to do this in a couple of stages. We've got 3 vials, or 3 early minor flasks, and we're going to add the Indigo Carmine. And you see how that turned green. So we're going to wait, sit here and wait for it to react. It will be about a minute.
While we're waiting. So what's going on is that Indigo Carmine, when we put it in solution, is green. But when it mixes with the glucose can give it an electron. Do you know about electrons? Have you heard of electrons? Yes. So atoms are made up of protons, neutrons, and electrons. So the glucose gives the Indigo Carmine an electron, and it turns red. And then, if we let it sit longer, it's going to give another electron, and it's going to turn yellow. The really fun part comes in. Once this turns yellow, we're going to shake it. And when you shake it, then it can act with the oxygen in the air, and oxygen loves electrons. So it's going to steal the electrons from the yellow carmine, and it's going to turn back to green. So we'll be able to actually cycle it through a couple of times. Now, you notice we started the second one so that they're going to each be in different stages at different times. We can see this one's getting ready. It's starting to turn from red to yellow. This is often called the chemical traffic light. Can you guess why?
Green, red, yellow.
Well, it's not in the right order because it goes from green to red to yellow.
Yeah.
But a real traffic light goes green to yellow to red. So it's a little bit different order. So as you see, now this one's fully turned yellow. So this is the starting color. This is after it's reacted with glucose for a little bit, and now after it's finished reacting with glucose.
But you shake that one down to red, and I'll shake this one down to green.
Okay. So if I shake it a little bit, it goes back to red. But if you shake it a lot, it goes to green. And if you let it sit again, it's going to turn back to red and back to yellow. Kind of fun, huh?
Yeah.
But the problem with this one, as we said, is that I bet you don't have Indigo Carmine and glucose and sodium hydroxide at home. And so this is not something that's really easy to do at home. However, let's go ahead and take these off. I know about another chemical that's in some everyday foods, and that's red cabbage. So the red cabbage has a natural dye in it. And this dye is a dye that will change colors with acidity, with pH. Have you heard of pH before?
Yes.
Excellent. So the pH will change when I add acid or if I add base. Let me tell you a little bit about acids and base. Okay, so in this case, the cabbage is red when it's acidic. It's bluish when it's neutral. I didn't have a purple marker. It's purple when it's a little bit acidic, green when it's a little bit basic, and yellow when it's really basic. Now when we talk about acids and bases, they're sort of opposites of each other. If water is neutral and I add protons to it, remember those same protons? Sometimes we write it as H+. If I add protons to it, it turns to an acid. And if I take away protons, it turns to a base. And so I end up having a range. We also put numbers to it. Maybe you've heard of pH numbers. 7 is neutral. Something very low like 0 is acidic. Something very high like 14 is very basic. And acids and bases are a little dangerous. Did you know that? If we have stuff that's way over here or way over here, that's actually dangerous to our skin. Our cells don't like it, and so it can burn. So we're going to get our safety gloves on. I'm going to get my gloves on. All right, so we're going to extract this out of the cabbage. I cut up some cabbage, as you can see, and I want to get as much of the dye out as I can as possible. So a couple things, I want to put it in some water, but if I use hot water, it works a little better. So I boil some water, and I'm going to pour some hot water in. Now, you don't have to have a big glass beaker like I do. You're fine if you just use a bowl or a pot. You can even put water in, put the cut up cabbage in, and let it boil for a few minutes, almost like you're boiling potatoes, and that will help extract it out. Now, another thing that works really great to really extract it out is to use a blender. It's okay if you don't have a blender, but if you do, you can see this really, I blended this and this really worked well. So we now need to strain out all the cabbage. So I've got a beaker, again, it could be a bowl, it doesn't have to be a beaker. And I've got a coffee filter, I've got a strainer. Either one of these will work on their own, but it together kind of makes it nice. And we're gonna pour this in and let it strain. And we may need to actually make some more from this. Okay, so while we're waiting for this to strain, Mr. Jerry, can you kind of finish straining that for me? Let's talk about what we're going to do. We want to test it by adding some acid or bases. And we don't know what's acid or base, so we've got some different chemicals. This is where it gets fun. Your job at home, once you make your cabbage juice, is that you can pick some different stuff. I've got some ideas on my board. The two general ideas would be food things. So milk, anything you eat. Orange juice, sodas, vinegar, baking soda, table salt, candies, egg, anything you want. Also, the nice thing, if you're dealing with foods can mix together. They're all eligible. So you could maybe try milk and orange juice together and see what happens. Make sure, again, you're working with an adult and your adult is approving. The other kinds of things we can test are things that are more things that we would not eat. Now, you have to be extra careful with these. Of course, you definitely need to ask an adult and know that some of these, if it's really acidic or basic, can be pretty dangerous. A lot of the cleaners we have to really watch out. Bleach, ammonia, toilet bowl cleaner, those are pretty strong chemicals, so you need to make sure that you're wearing gloves and mom and dad approve and they're working with you on those. So cleaners are a great source because a lot of the way cleaners work is by acids and bases. Shampoo, that's one that's not so dangerous. Seltzer tablets, you know, when you have an upset stomach and you have one of those seltzer tablets. Ammonia. Hand sanitizer, we all have a lot of hand sanitizer around. So there's a variety of things. I have a bunch on my table and we can work on these. So we're gonna put some of our cabbage juice in some beakers. You have beakers at home, Stephen?
I do not have any beakers at home.
Uh-oh.
Uh-oh.
Does that mean you can't do the experiment?
Absolutely not. I hope not.
So what would you use in place of beakers?
I could use a little jelly jar.
Yeah. So, or a drinking glass?
Or a drinking glass.
It would be nice if they're clear so that you can see through them. And it's nice if they're made out of glass. Plastic works too, as long as you don't use dangerous chemicals with it, because sometimes chemicals can melt the plastic. So glass works really well. So if you have some drinking glasses, again, make sure before you raid the cabinet that you've asked your permission from your adults. So we made some more juice that we didn't quite have enough, so we made some more and I put them in some smaller containers so we really can see what's going on. Now, I want to show you what's really acid and really base. So I've picked out some ones. Again, I'm going to use ones you don't have home. So I have hydrochloric acid and I have sodium hydroxide. So these are the strong ones. So let's go ahead and add a couple of drops. And we're going to see, this should turn really red. So we see you get a very red. I might even add a little bit more. Because again, more acid means more color change. And see, this is about as red as you can get it. Now, if it's testing this red, that means this is not something to play with. The other one on the other end, I will use some sodium hydroxide. And when we shake that up, we get a nice kind of dark green. If you can get it really dark, it'll turn a little bit yellowy. Let's see. So we can see a little bit of yellow in the foam, but you get like a greenish yellow. Again, if you're getting this kind of green, that means it's probably a little bit too much to be playing with. Okay, there we go. Kind of, it's still a yellowy green, but yes, we get, so that's very basic. Okay, so this is neutral, this is basic, this is acidic. I'm gonna try some ones that are in the middle. So this is isopropyl alcohol. I'm gonna have to use a bunch of it, but it's a little bit acidic. Not very much, but we'll see. I get a number of color that'll be in between this blue and the red. And you can see, so here is my blue, and this one's more of a purple. Now, if I had something that's maybe maybe a little more acidic than the rubbing alcohol, it might be a little bit more purpley than that. And you know what these are?
What are these? These are Antacid Tablets. Yes.
So sometimes, you know, a lot of times we know adults in our life who take these after they eat when their stomach's upset. These actually work because in your stomach you have acid. Mm-hmm. That's what our stomach has acid in it that helps break down our food. And this is not yet open.
New antacid.
It's new antacid. And also when you have these, sometimes these work good if you break them up a little bit. So this actually works by settling the acid in your stomach because it's a little bit basic and it will neutralize. And let me take another one. So of course I could have just chopped this up, like put it in a bag and use a rolling pin on it, but we are using a mortar and pestle. So this is what chemists use when they're trying to get a nice fine powder. And now the powder should be able to interact. And if I'm doing it right, I should get something kind of greenish. Well, this is what happens with experimentation. It kind of looks like just milky purple, or milky blue. So we might add something that's a little bit more. So another thing that's basic might be some ammonia. Ammonia is actually a little bit basic. So I'm going to add just a little bit. I want to add it from here. Of course, I'm in a little container.
It's going green.
Is it turning green?
Or it's going blue, actually. Like
an in-between, yeah. And of course, when you put powdered stuff in there that doesn't dissolve, you get the opaqueness too. So there we go. So something that's more of a blue-green. I added, so notice I said you can't mix stuff. I kind of broke my rules. But I do know what these chemicals are, and I know that these two chemicals are safe to mix. Maybe a little more. So you see we get a range. Now, this is where it cuts fine. So at this point, now that we understand that this would be acidic and this is basic, so we're going from red, purple, blue, green, yellow, then we can start playing with different stuff in the kitchen. So I'm gonna let you pick two. I'm gonna show you a whole bunch of different ideas. I've got some baking soda. I got some candies crushed up. I think these are sweet tarts. I have soy sauce and hot sauce or sriracha sauce. Hot sauce. What about a packet with sugar substitute? Lemon, crab oil, cornstarch. I've got some salt. We've got vinegar. So we've got lots of different possibilities we can try, and I'm sure you have even other ideas at home. So this is where we can try stuff. Sometimes it might just be neutral and it might not change, but here's where we get to change. So what do you think?
Gotcha.
What would you like to try?
Based on my super rudimentary knowledge of chemistry, I know that isn't baking soda a base and vinegar and acid?
It is. Would you like to try baking soda in one and vinegar in another?
Absolutely.
All right. So we've got our baking soda and vinegar.
Just a little
Now,
bit.
since you got your we have a little whey boat over here.
Okay.
If you want to pour it in there and then dump it in.
Yes, that seems much easier.
But you got your gloves on. You could have just put it straight in your glove. That's okay. Sometimes science is a little messy.
Science being messy is the fun part. Should I push this a little bit?
I might crush it with your finger a little bit and then just put a little bit in.
There you go.
If you have a spoon or something, a little bit, you can use a spoon to kind of dump a little bit in.
Is that enough? Should be more?
Same.
That might be
Maybe a little bit more.
Ooh,
Yeah, that's okay.
that was a lot bit more.
So remember, this is my neutral. So this definitely does look a little bit basic. We'll put it on we're putting bases on this side. And let's try
To the
some
left, after
vinegar.
to the right. Ooh.
And that turned pretty dark.
Pretty
Not
pink.
quite as red as this, but pretty red. So we definitely see that vinegar is acidic. A lot of things that have a sour taste tend to be associated with acids. A lot of things that sometimes have like a slippery taste can be associated with bases. Not that we eat those, but there's a lot of acids and bases in food we eat. You know what would be neat? Should we add these together? These are both foods, right? We can
Yeah.
add things as foods
Okay.
together. Why don't you try adding them? See what
So
happens if we
add
mix them.
together.
What do you think happens if you add an acid which has a lot of protons in it and a base? Yes, it might float. We do know that also baking soda and acid react. It might get a little fizzy. That's okay.
Let's see.
We got a lab bench. We're all right if we make a little bit of a
All right,
mess.
I'll move this stuff out of the way just in case. And should I do it all?
Sure.
Okay.
Woo. Okay. And it did go
I
over.
just
So we are getting two things going on. The baking soda and the
And the
vinegar
vinegar.
actually react together and they make carbon dioxide bubbles. So we got a little bit of that going on. So that was the fizzing and the foaming. And then we also see we got a color change and it turned back to kind of a blue. It's a little hard to tell, but we're pretty close. So they kind of neutralize each other. Kind of like what was happening in the stomach with
Yeah,
the
with the
antacids,
antacid.
is that the acid in the stomach can get counteracted and neutralized by the base in this. All right, so we got two more. I'm gonna move this one off to the side.
I don't know.
You wanna try hot sauce? What do you think from the taste of hot sauce? I have a guess. I've never done this.
I would say if it burns your tongue, it might be acidic.
Let's see if it's acidic. Let's see if I can open it up. Because I can't use my teeth when we're in lab, can I?
No.
That's what I have my friendly lab coordinator for.
Thanks,
to
Mr.
help.
Jerry.
All right, Mr. Jerry, let's see what we get.
Here we go.
Woo! That's pretty dark, right? That's definitely towards the acid end.
More acidic than this was rubbing alcohol?
Yep, yeah. Oh yeah, and rubbing alcohol is only a little
Yeah,
bit
only a
acidic.
little bit.
All right, so last one, you want to do the sweet tart, were they sweet tarts? Sweet tart candies?
Sweet tart candies.
Let's see what sweet tart candies do.
That one?
Yes. This is the one we haven't used yet. And you know how I know? Because it's the color blue.
This is the color blue.
Could you do a science project, do you think, with this? Think this could work for a science project, an experiment?
with
If
my.
you wanted to do this at home, if somebody needed to do a science project for a class, could they kind of make this into an experiment?
Oh, absolutely.
I think so, yeah. So this would be a great idea. Some of the things when we do a science experiment like that, we like to make sure we control things and only change one thing at a time. So you could try changing which chemical you use and make sure we're using the same amounts of indicator. You could try using different amounts. What if you add just a drop of vinegar? What happens if you add a teaspoon of vinegar? What happens if you add a quarter cup of vinegar? Does that make a difference? So you have all sorts of stuff. I know you have a lot of things that you're bored at home this summer, so this should provide you a good afternoon, a good weekend of fun stuff to play with.
Well, I think that's all the science we have today. So if you are doing this for summer reading participation from home, if you are under the age of 12, your secret code is INVENT, that's INVENT. And if you are a teen at home, your code combo is WE ARE, as in we are so glad you had us in your science lab today, Miss Gina.
I had a lot of fun if you can't tell. Thank you. Have a great summer of science.
See y'all next Saturday.